Okay, with sodium acetate. Well, first, here's a nice bottle of sodium acetate. Now, if you can't be bothered to work out the molecular weight of the compound you're going to make a solution of, sodium acetate in this case, then look at the bottle. Manufacturers very kindly write the molecular weight of the compound on the bottle, and here you can see, look close enough, yeah, we see sodium acetate molecular weight 136. Won't bother about that 0.08. I'll tell you about that, why that is later. And then they've written the molecular formula on, so we can check, see whether we've got the right material. Yeah, so 1.36 grams of this. Need a balance, of course. Here's a nice, beautiful balance, modern balance. First we need to tare the balance, which resets it to 0, and then weigh out 1.36 grams. Right, there you go, 1.36 grams. Okay, well, if I close the door on this balance to get accurate reading, you can see it's just off. Now, I'm going to ignore that, along with the 0.08 that I mentioned before. I mean, anything less than 1% error on making up this type of buffer is making absolutely no difference to its function. So I can work to a 1% error quite happily. So transfer it quantitatively, which means basically not dropping it on the floor. Now we proceed to dissolve this. So you remember we wanted 100 mils of this. So at this point you can see these conical flasks are actually graduated, which is quite helpful. I'm going to add slightly less than 100 mils to dissolve this, and you'll see why that is in a minute. So here's my water. Add it in until we get up to near the mark, but actually somewhat below the mark. And to aid this dissolving, we can add a magnet. Let's do on a stir. See, that's now dissolving. Now, the next question is the pH. Well, I've got a pH meter here. The probe is up here. Keep it in a stabilizing solution. So, put it in this bracket at the top. We just need to wash this off. Get rid of the stabilizing solution that it's been stored in. Just wash our electrode. And we place it in the solution. Bring these two slightly closer together. See what we're reading. Focusing on that. Slightly above our required 7.0. So we've obviously got to bring the pH down slightly. We'll do this by addition of dilute acetic acid. So we won't alter the change ionic composition of this very much, but we'll add some acetic acid. Remember, we're dealing with sodium acetate here, so it's the same anion in acetic acid. We'll bring the pH down. A little bit more acid. Coming down gradually, 7.04 now. Oh, there we are, 7.00, and that's steady. So we can put that back in the electrode back up in the stabilizing solution. So it can stay there for, turn off the stir, and then we now make this up to 100 mils, and I've got a measuring cylinder here. The marker you can see. Trick is here not to pour out the magnet into the measuring cylinder. I will want to remove the magnet, however. So I can then add all the liquid, and you need to wash out that first conical flask with some sodium acetate still in there. Transfer that also to the measuring cylinder. Now I now bring it up to 100 mils. So you can see now why I added somewhat less than 100 mils when I started off making up my initial solution, because at this point I would well overflow. I've gone much further than the 100 mils, and it would not be 0.1 molar. Just a little bit more. Just washing it out bit by bit, and there we go, 100 mils, right on the line. The meniscus is on the line. That's what we want.